This is Jeanmarc from MilliBox, and today we're in beautiful Boston for IEEE IMS 2026. So for those of you that are lucky enough to come to the show from Tuesday to the exhibition, please come see us, booth 13075. And for those who can't make it, then I'm going to show you as if you were here. So let's get started. So here we are showing the radar demo at IMS 2026. So basically it's an MBX32R where we're showing a MilliBox setup in conjunction with fixed target and mobile target and virtual targets. So we're using the virtual target simulator from Air, which is our partner for this demo. So that's a virtual target simulator that we mounted on the Wall 9, which is our instrumented wall specially designed for radar. The radar market is a very important market for MilliBox. We have many customers that are doing some kinds of implementation based on this. It's more like a platform where you have the software. You can integrate the software into your radar test environment, or you can integrate your test environment as part of the MilliBox software, whatever is easier for your application. The goal is that you can use a MilliBox chamber to make RF metric, gain, radiation pattern, and so forth. See if you have any impairment due to enclosures and due to, in 3D. That's how you want to detect if you have blind spot and things like this, right? That's one of the activities that you can do with a MilliBox. But also you can train your radar. You can exercise your radar against, different targets and to see the performance, the actual performance, using, integrating the data like we did, like FFT and Doppler into the Python framework that we have, and then start making some graphic representation of your test cases and integrate that into a compelling test setup for your radar. If you're into mmWave and sub-THz radar, don't hesitate to come and talk to us about some combination that you can use for your application. One of the demo that we're showing at IMS 2026 in Boston is this MBX2K, which is the MBX2 chamber with a gimbal 6, where we are measuring an antenna. The DUT that we have is from Air. It's a dual reach, very wide antenna from 14 GHz to 110 GHz. And so it's hooked up with their very flexible 1mm coax. And then we connected it to that incredible VNA for Enritsu that has a band from 70 GHz to 110 GHz, one trace. So what the interest of that for us is that we have a trace of 97 points, which is 1 point every gigahertz. And we're collecting the entire trace, which is 97 radiation pattern in one shot. So we're showing the power of our software integration with the power, of course, of the VectorStar ME7838 from Enritsu, and we combine. We have a crazy wide solution that shows the versatility and the usage you can do from 14 gigahertz to 110. There's so much you can do with a setup like this. So that shows those capabilities in a single setup. Of course, we have some implementation, and we show other implementation with frequency extenders and system like this, where it's concentrated in a particular band. But what if you wanted a system that can do it all, like a Swiss knife of radiation pattern capture, and that would be a setup like this. Yeah, so that's one of the demos that we are showing at IMS 2026 in Boston. That's the complete mmWave and sub-THz OTA setup with the CATR. So we're using the MBX32 CTR. That's something you've seen before with the Gimbal 4 300E, which means with embedded extenders, and then the parabolic reflector coming from Air. But now the new things that we're introducing is the FST capability. Remember, I did some video on that, you can check it out. FST is the ability to capture traces right on the fly, or radiation pattern right on the fly without a stop-and-go platform, but with pulses that comes from the motor of the base and then hooked up to the trigger input of the VNA. Speaking of the VNA, we're using the beautiful BFX02 from Copper Mountain Technologies. that they just launched recently and that we're going to use extensively. That's basically a VNA head that's connected to extenders. So if your application is that you only use extenders for all of your measurement, the BFX2 is really your friend, because it doesn't have all the bells and whistles of other VNAs, but it can do the same thing if it's connected to extenders. And those extenders, they can go to 1 terahertz, depending on which you use. The one we're using in this demonstration are the VNAX M2 form factor, TXRX on both sides from Virginia diodes. You should check it out. Those are extremely useful due to their compact size. That is ideal for 3D radiation pattern, which we are doing here. This entire setup is in E-band, 75 GHz to 110. With the FST, we take this entire plot in like minutes to capture the entire 3D radiation pattern thanks to FST. So, to make it short, we show CATR implementation with the MBX32 CTR. We're showing the BFX VNA. We're showing the new VNAX from Virginia diode extenders, and together with the FST, the fastest radiation pattern you've ever seen. So if you're at IMS, that's one demo you should not miss. Okay, that's the best on the floor, the most versatile that you can use for so many applications. If you're in the domain of testing antennas from mmWave to sub-THz, mainly from 10 GHz to 330 GHz or terahertz, that's the setup that you really want to see in your lab. So I hope that gives you some reason to come and see us. We are super excited to be here, and we hope to see you guys on the floor. We are at IMS 2026, booth 13075. That's where we'll be here for you guys. If you can't make it, don't hesitate to contact us, and we'll be glad to show you those demos privately online. Thanks a lot. Talk to you later. See you soon.